We're going to go ahead and do our Q&A. I'm going to come back here so I can read some of the questions and repeat it for the audience and just use the microphone.
Does the water just percolate away? How do they work? You can't tip it over.
Yes, you would have to wait for the water to either evaporate or percolate into the soil. And one of the bigger challenges with the pits is you have to dig the biochar back out of there, and then you're going to mix it with the subsurface soils that are not so good, that you probably don't want in your ag or garden approach. So those are some of the challenges aside from the safety issues with pit biochar production. Answer your question? Yeah. Did I just repeat the question? I don't know if I did. I'll try harder.
So then we also have a question from the chat. What range production of biochar output, pounds per day, comes from, say, a BB12?
Okay, it's a great question. Of course, it always depends on the fuels, how dry the fuels are, how dry the air temperature is, but we'll fill that kiln and empty it twice in an average 8-hour day. And each dump, if it's pretty full of coals, I would venture to guess that is 3 to 4 yards of biochar. So perhaps 8-ish yards of biochar daily. Wild guess.
I had a question.
Oh, okay.
So have you had a chance to check the temperature during pyrolysis?
Yes,
Yeah.
Tends to be in the 600-degree area.
Okay, great. Yeah,
yeah.
not too high for
No.
these soils. And with wood, you shouldn't have too much of an salinity problem either.
I'm finding it depends on the wood.
Okay.
Russian olive and salt cedar have much higher salinity
Okay.
problems. And I think that Russian olive, that characterization sheet showed that Russian olive was 8.5 pH.
Okay.
And so I am coached to mix it with manure and at least a 1-to-1, maybe 2-to-1, 3-to-1, 4-to-1 manure to char, and let it sit for a few weeks, and that will ameliorate that problem. Please speak to that.
So yeah, mixing manure with biochar to lower the pH does make sense to me theoretically. I haven't tried it personally. I always wanted to get into the compost and manure area, never did. But what should happen in theory is if you let manure sit, or even just kind of biomass, kind of moist biomass, if you let it sit there, the microbes will start transforming the organic nitrogen into ammonia first, so NH4 plus, and then with enough oxygen, it will oxidize that to nitrates, so going from that positive charge to the negative charge one that we talked about before. And that process also produces hydrogen ions, which should lower the pH. The manure pH itself should be lower, but that could be affected by the animal source or what they were eating. But yeah, mixing biochar with other products like manure and compost can really ameliorate the high pH that's common in biochars. Yeah.
And I almost never tell people to put it directly on their gardens. Always put it in your compost pile or mix it with manure first, and then, because otherwise it can rob a lot of the nutrients and moisture from your soil in the short term.
Oh yeah, that was another question in the chat. That was a really good question, that what happens if the biochar absorbs too much nutrients? It doesn't happen too often because plants are very crafty. They use acids to displace the nutrients from surfaces in organic matter and biochar. So a lot of the nutrients in biochar are surprisingly bioavailable despite that sorption process. That said, if you apply a lot of biochar to an already nutrient poor soil, it could tip it over the edge. Like it could just, so it wouldn't be, I wouldn't expect too big of an effect, but it could be enough of a problem that, yeah, you would want to apply it with compost or manure, or at least fertilizer of some kind. Yeah.
And
So we've got another question from the chat here from Dean. For an intro/garden size kiln, Will a metal garbage can work, or is it too deep?
No, I think would a metal garbage can work for making biochar? I think it would work just fine.
I've also seen examples of metal garbage cans, of water or oil barrels you can use just one, or if you want to have a covered system or perhaps one with a small hole on top instead of a full flame cap, you could turn a second barrel or trash can upside down and put it on top of the first one.
I would be cognizant of the treatment of the metal and what it was putting off. If it was typical garbage cans are galvanized or treated with other things. So at least get away from that smoke that first burn or two.
And then we have another question from the chat from S. Thalberg. What about putting 5 to 6 shovelfuls of biochar around the base of seedlings? Will this rob the tree of nutrients or help hold in water during the hot summers?
I will let you.
Okay, so first you definitely want to wet the biochar to keep it from sucking out water from the soil. And as a precaution, I would recommend co-applying with, like if you're applying to a seedling tree, co-applying some compost, and you can even put mulch on top of that biochar to keep it from blowing away. So with biochars, unless you have a lot of data on the biochar that you're using and people have thoroughly tested it, that it doesn't inhibit seed germination, for example, or inhibit growth of any particular plant, just err on the side of caution. Mix with some nutrients, add extra water more than you would usually, just in case there is a problem. You could dilute any toxins, wash out the extra salts, and add those nutrients just to make sure the biochar isn't sucking too much out of the soil. But long term, the biochar will sort of reach an equilibrium. It'll become stable in terms of the amount of nutrients it's absorbing, adsorbing to and from the soil. And so long term would not be an issue.
I know that you've, anyway, here's the question. If we were going to talk with gardeners on doing co-composting with biochar, what would be a general range that they could put a percentage into their compost? Because I know, what is the wood? I imagine they're using their wood waste, whatever they're trimming, the tree trimmings are. What would be a percentage that you think would be good, or where would they be too much?
So on the top of my head, I can't put my finger on it. The student I'm working with, Shelby Hoagland, has done some research on that, and I'm happy to provide some of those materials. I want to say order of magnitude, like super ballpark, between 1 and 10%. I wouldn't exceed 10% unless you're having some kind of problem you're trying to alleviate. Biochar, you don't remember, do you, the rate? The biochar can aerate the compost during the co-composting process. So it's thought that instead of just mixing the biochar and compost and applying it to the soil right away, if you co-compost, that improves the aeration of the compost and helps the microbes decompose the organic material faster.
Now we've got a couple more questions in the chat here. The first one is from George. What is the hurdle at the moment to commercializing biochar? Is the technology already there?
In my opinion, the technology is there for production. The markets are what are most lacking. Most people have never heard of it. And so why are you going to buy it if you've never heard of it? You don't know what value it will bring. So the question was, what is the bottleneck for biochar sort of taking off? And I think it's markets and awareness is my opinion, but I will defer to Rivka for.
So I agree with that. If there's market limitations right now, I'm not completely up to date on the biochar market, but it's been that way for a while. There's been a slow but steady increase in the number of biochar companies out there. There's plenty of technology. The only technological limitations that I'm seeing that are still a problem right now are actually related to the bio oil, not the biochar production. So trying to make bio oil production economical is more difficult because multiple reasons. It's hard to get high efficient yield of that product. It can be expensive to refine it, and the economic viability of that obviously depends on fluctuating gas prices. So for a long time, people were saying that a carbon credit will be needed to make bio oil viable. If gas prices stay high, that might not be the case, but the economics are getting better with technologies like autothermal pyrolysis, which I talked about before, adding just enough oxygen to make the overall process more efficient and increase the oil yield. That helps a lot. And there's also some fractionation technologies to get the rest of the biochar. So the bio oil, I mean, because the bio oil is kind of like raw petroleum. You have to refine it, but the process for doing that is quite different than from petroleum, and they're still working on it.
So I'd like to comment on that. When we got that Sun grant to scale up our mobile pyrolysis machine to 20 tons per day, it was about a $500,000 grant, and $100,000 of it we used for testing bio oil and trying to find a market, a usable, simple way to refine it and get it out onto a market. And at that time, this was in 2015 thereabouts, we did not hit that home run. We didn't find a way to do it. I'll go ahead and ask Rivka this question for her response. Related to bio oil, I spent an hour or two on the phone Monday morning with two entrepreneurs, one from the UK and one from Germany, and they were very interested in using the bio oil for carbon sequestration by pumping it down into abandoned oil wells. And I have environmental concerns about this approach. I know nothing about it. This is what I told them. I'm happy to work with them in the meantime to help them understand the bio oil and making it and that sort of thing. But just wondering if you have any reactions to that.
That great question. I've never heard of injecting bio oil into the ground to sequester carbon. I would say that the biochar is a much surer bet in terms of sequestering carbon long term. So the problem with injecting anything into the ground is everything goes someplace eventually. So it's similar to trying to inject carbon dioxide into the ground after combusting fossil fuels. The gas could escape should any of the rock formations or underground water bodies into which you're injecting that, should they become destabilized for any reason, then the gas or liquid would escape very suddenly. And with bio oil, while it's not as toxic as petroleum, you would not want that getting into groundwater or moving upwards towards the soil. That would be really disastrous. So I would caution away from using the bio oil in that way. I would rather see it used for fuel, or it can be used to make bioplastics.
Mm-hmm. Yeah, epoxy Novolac resins in particular. I did a bunch of work on that, trying to make plastics. You can make durable or recyclable plastics with this material. And do you know, related question, do you know the organic carbon content of bio oil-ish?
So it's lower than biochar. I want to say closer to 30% or so carbon in the bio oil. And another interesting use of bio oil that these companies might be interested in is using it as a binder to keep particles together so biomass particles or some other combustible fuel particles for making pellets. So like a wood fire pellet stove or something like that, that could keep wood or some other fuel better together, and better yet, maybe use some kind of waste wood that's not normally, or other waste product that's not normally combustible easily, keep that together in handy pellets.
Thank you. Chris?
An attendant, she had a question about the pH of the quench water. And so Lisa gathered a little bit and put a little strip in there, and it looked like it's higher than a 9, you know, so
Yeah.
just any type of discussion on concerns about that quench water, because we're just dumping it back on the land.
Well, I'll just say that I asked that question of Kelpie Wilson this morning by email, and I haven't checked in a little while, but I don't know, but I'd like to hear.
So with pH, basically water is much more sensitive to the alkalis in biochar compared with soil. So mixing biochar with just water will result in a much greater pH increase compared with mixing biochar with soil. And that's because soil has a much greater concentration of buffers. All those soil particles, especially the clay particles, can absorb, can stick, retain acids and bases. And so that keeps the pH much more steady. So I haven't pursued this myself, but I can say that it's most likely quite safe to take that rinse water, maybe dilute it to be safe, and then spread it as widely as possible to effectively dilute it in the soil. And then I would expect a pH increase in the soil, but it might be very small so long as you keep that water diluted as possible.
And I'll just say from experience, every time, you know, I've dumped a lot of kilns, big and small box kilns. I don't always go look at that site afterwards, a year or two later, but I've yet to see any impact or have any impact reported from where we dumped our quench water.
Yeah.
Ben?
So we've got 2 more questions in the chat here. The first one is from Renal. Sorry if I pronounced your name incorrectly. What might be the optimum dimensions, height and width for pyrolizing using long piles rather than a tall and wide pile, assuming length could be almost anything?
So the question is, what is the optimal length of a kiln? Am I interpreting that right? To make biochar? I would say it partly depends on your fuels, and it could be a variety of things. First of all, the physical part of it. If it's too long, too spread out, it's going to be really hard to make it consistent and have that flame cap form. My research and experience is limited this way. I've only gone as far as 16 feet and had no problems there. Very interested in doubling that and working in the future and see how far we can go. But that's where I think we're going to see the limitations, and a consistent flame cap and consistent heating throughout the kiln. That said, the other practical measures include, are you moving a lot of feedstock to that kiln? If it's long, skinny feedstock, logs, bamboo, that sort of thing, yeah, long kilns work great. But if it's 32 feet, it's going to be much harder to move around on a site. I should say, regarding moving around the kilns that I have, even when they're running, we can drag them around. They have skids on the bottom. They have fork pockets on them. They have eyelets on them for towing them, but I'll just hook a couple of cables to it and hook it to the back of my Tacoma and drive it across the site. We can go hundreds of yards or quarter mile or as far as you want to go. Even it's kind of fun when they're burning to drag a burning kiln around. But so transportation would become an issue there. Do you want to say anything about that?
I don't have any comments on that. I did have a question for you and then an update on my comments about compost. So regarding the, sort of related, you were saying before that at some sites you like to bring the larger pyrolyzer with you and some smaller pyrolyzer, and something to do with the amount of wood there. Was that the density of the trees or the size of the tree trunks? What was going on there?
Well, I like to get to a point. The question is, how do you decide which kilns to bring where and what? I'd like to get to a point where before we even start logging a property or thinning or that sort of thing, we write a forest management plan or a logging plan or prescribed fire plan. We write a biochar plan, and we decide we're going to need 4 big box kilns, 3 and 4 BB12s for out around the landings, and then several small kilns, maybe 8 small kilns for back in the woods, that sort of approach. So it would depend on the fuels and how spread out they are. I hope this information is practical for that question. I've run 2 or 3 kilns at one site at the same time, and I find that a mini excavator, if the fuels are piled and fairly concentrated, we keep our kilns right next to each other. Then the excavator can run back and forth and tend several kilns, perhaps even up to 4. I haven't gotten that many at once yet, but I'm working towards that. I find that if we spread out the kilns on different piles, a kiln by each pile, and those piles are a quarter mile apart, then the excavator has to spend too much time running back and forth, and that crushes your productivity. So you want to sort of concentrate all your work, especially if you have a piece of machinery, all your kilns around that piece of machinery. So it'll depend on very much on how diffuse the fuel is, how concentrated it is on the landscape, and what prescription of kilns you might want. Do you think that answered the question, Ben?
Yeah,
Yes.
we've got 2 more questions, and we're going to try to answer both of them in about 5 minutes. So the first question is from Dave. Are different types of wood better for different use cases, and such as crops, synth oil, gas, filtration efficacy?
I'm so glad Rivka is here to answer that question.
Yeah, so excellent question. So generally speaking, hardwood is going to have the highest density. It's going to most likely be better for carbon sequestration because it'll have a higher percentage of that stable carbon in it. Softwoods are, in theory, better for retaining water because they have a lower density, and so they're going to have a greater porosity to retain that water with. And then, of course, the grasses are going to be best for retaining water. And you want to use a waste feedstock whenever possible. I did have an update if there's a couple of seconds. I just got a text back from the author of the compost study that I was referring to, where they improved the wheat yield by applying biochar compost. That was actually a 50-50 mixture, approximately. I did a back of the envelope calculation. So you can go quite high with the biochar. I certainly would not want to exceed 50%, but I guess it's kind of hard to go wrong. During the composting process, though, you can see a difference at the lower biochar application rates.
And we'll say with our open box kilns, I've done perhaps 20 different kinds of woody feedstock, Russian olive, tamarisk, aspen, every upland conifer. But with our high-tech kilns, we've done probably 25 to 30 different kinds of feedstock. Things as crazy as wool, dacron, Phragmites, invasive swamp reed, tires, auto fluff, recycled material. So pretty versatile and robust. Next question, please.
And then the final question from the chat, if we can answer this in about 2 minutes. From George, he said, can biochar be developed into potting mix? I heard that a rooftop garden in Malaysia uses biochar in the container as the growth medium. Is it just an amendment or 100%?
So it would just normally be an amendment. It is possible to grow plants in just biochar. However, whether that's going to work or not is extremely hit or miss depending on the biochar. So there's much more robust evidence suggesting that mixing the biochar into the potting material, possibly displacing more alkaline potting material ingredients like perlite would make a pretty good potting mix. And yeah, I'm happy to answer those questions over email in greater depth.
Live question.
Didn't your illustration from Copenhagen, didn't that show their roots are in the biochar
Yes.
completely?
Yes. The question is, did my illustration from Copenhagen show that it's in the roots are in the biochar completely? That's a structural soil. Can you comment on that, Rivka?
So I don't know as much about what was going on in Copenhagen. But yeah, I've heard of instances of growing plants in pure biochar, and it can work. So you just have to carefully balance the different properties that I was talking about, and not have too much of salts or alkalis or anything like that. It can work, but will probably require, if you really wanted to grow something in just biochar, you would have to carefully adjust the amount of nutrients to meet the plant needs before putting it underground like that.
Almost like hydroponic gardening,
Yes.
it sounds like.
Yes, hydroponics is not an area I have much experience with, but I'm really excited about the potential of biochar in that area.
Okay, so thank you very much.
Thank you.